I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. In today's lecture, we'll be looking at redox reactions. Our lesson objectives for today's lecture: at the end of the lesson, students should be able to define redox reaction and associated terms, identify oxidizing and reduced species in the reaction, explain and use the term oxidizing and reducing agent, identify oxidizing and reducing agents in the reaction. So please, I want us to listen attentively and get the best out of today's lecture. So when we talk about redox reaction, the word redox is coined from two words, reduction and oxidation. So redox is an acronym, which is reduction, and oxidation is coined from two major words, reduction and oxidation. The red stand for what? Redox, and the OX stand for what? Oxidation. Now we'll talk about reduction and oxidation. Most chemical reactions are redox reactions. Example, combustion reaction is a redox reaction. Respiration is a redox reaction. Electrolysis, electrolytic reaction that takes place in an electrolytic cell is a redox reaction. So most chemical reactions are redox reactions except neutralization reaction and precipitation reaction. Now we'll talk about neutralization reaction, which is the reaction of an acid and a base to form salt and water only. Let's take, for example, this is a redox reaction. Sodium hydroxide reacts with what? Hydrochloric acid to form salt, which is sodium chloride, NaCl, plus what? Water. So it's not a redox reaction. If you have to calculate the oxidation number of each of the elements present, you discover that there's no change in the oxidation number. Oxidation number of sodium here is plus 1, oxygen is minus 2, hydrogen is plus 1, hydrogen here is plus 1, chlorine here is minus 1, sodium here is plus 1, chlorine here is minus 1, hydrogen here is 2 bracket 1, oxygen here is minus 2. So if you look at the oxidation number, minus 2 plus 1, minus 2 plus 1 is minus 1. 1 minus 1, oxidation number here is 0. Plus 1 minus 1, oxidation number here is 0. Plus 1 minus 1, oxidation number here is 0. 2 times 1, 2 minus 2. 2 minus 2 is 0. So you describe that there is no change in the oxidation number. So neutralization reaction is not a redox reaction because there's no change in the oxidation number of the reactants and also what they produce. Now let's take an example of a precipitation reaction. It's not a redox reaction. Let's use silver nitrate. For example, silver nitrate reacting with sodium chloride to form a precipitate of silver chloride, to form a precipitate of what? Silver chloride, AgCl plus sodium nitrate, which is NaNO3. So this is a precipitation reaction. So this is the precipitate of silver chloride that is formed. A precipitate is an insoluble or solute in what? In a solution. So let's calculate the oxidation number of each of the elements here. Oxidation number of silver here is plus 1. Oxidation number of nitrogen here is plus 5. Oxidation number of oxygen here is minus 2. So to be plus 3 brackets minus 2. Oxidation number of sodium here is plus 1. Chlorine here is minus 1. Silver here is plus 1. Chlorine here is minus 1. Sodium here is plus 1. Nitrogen here is plus 5. Oxygen here is plus 3 bracket minus 2. So if I had to calculate the oxidation number of each of them, 3 times minus 2, 3 times minus 2 is minus 6. So 5 minus 6 is minus 1, plus 1 to be 0. Plus 1 minus 1 here, 0. Oxidation number of sodium here is plus 1. Oxidation number of chlorine here is minus 1. So plus 1 minus 1 here is 0. Plus 1 minus 1 here is 0. 3 times minus 2 is minus 6. 5 minus 6 is minus 1. So plus 1 minus 1, oxidation number here is 0. So if you look at the reactant and product, there's no change in the oxidation number of each of the reactant and product. So it's not a redox reaction. So most chemical reactions are redox reactions except neutralization reaction and precipitation reactions, where there's no change in the oxidation number of both the reactant and the product. So please, I want you to take note of that because it's very, very important. So looking at redox reaction, which is an oxidation reduction reaction. So redox reactions can be explained in 4 different ways or can be expressed in 4 different ways. So we're going to take the first one. Redox can be expressed in terms of electron transfer. So we'll talk about oxidation. Oxidation is the loss of electron. Oxidation is the loss of electron. So highly reactive metals like zinc ionized by losing electron to give you what? Zinc ion plus 2E minus. So zinc is what? Oxidized. Zinc is oxidized. So which is the loss of electrons. So it loses electron to form was zinc ion. Then reduction is the gain of electron. Let's take for example copper, which is a less reactive metal, goes to copper, less reactive metal gains oxidize, undergo reduction to give you what? Metallic copper. So copper here is what? Reduced. Reduction is the gain of electron because it gains electron. So reduction is the gain of electron, while oxidation is what? The loss of electron. In terms of electron transfer, oxidation is loss, while reduction is what? Gain. So we use the acronym OIL, which is oxidation is loss. Then we use the acronym RIG, which is reduction. Reduction is gain. So we use the acronym OIRIG to define what? Oxidation and reduction in terms of electron transfer. Oxidation is the loss of electron, while reduction is the gain of electron. So it's as simple as what? A, B, C. So looking at oxidation reaction, redox reaction in terms of the addition and removal of oxygen and hydrogen. We talk about addition and removal of oxygen and hydrogen. Now let's start with oxidation. Oxidation is the addition of oxygen to a substance. So the substance that oxygen is added to is the substance that undergoes oxidation. So oxidation is the addition of oxygen to a substance and the removal of hydrogen. So when hydrogen is removed from a substance, that substance has also undergone what? Oxidation. So oxidation is the addition of oxygen to a substance and the removal of hydrogen. So let's take, for example, this is copper oxide, reacts with hydrogen. So to give you what? Copper plus water. So if you look at what we have here is that what? Oxygen is removed from what? Copper 2 oxide. So copper 2 oxide undergoes reduction. But oxygen is added to hydrogen. So hydrogen undergoes what? Oxidation. So we say oxidation is the addition of oxygen to a substance and removal of hydrogen, while reduction is the addition of hydrogen to a substance and removal of oxygen. So you can see that copper 2 oxide is reduced because oxygen is removed from copper 2 oxide. So copper 2 oxide is reduced to copper, while hydrogen is oxidized to what? Water. Hydrogen is oxidized because oxygen is added to hydrogen. So in terms of addition and removal of oxygen and hydrogen, oxidation is the addition of oxygen to a substance and removal of hydrogen, while reduction is the addition of hydrogen to a substance and removal of oxygen. So this is the definition of what? Oxidation and reduction in terms of addition and removal of oxygen and hydrogen. So looking at oxidation reduction, we want to look at redox reaction in terms of the addition and removal of electronegative and electropositive elements. So in terms of electronegative and electropositive elements, when we talk about oxidation, oxidation is the addition of an electronegative element to a substance and the removal of an electropositive element. So in terms of electronegative and electropositive element, oxidation is the addition of an electronegative element to a substance and removal of what? An electropositive element. So when we talk about electronegative elements, non-metals are highly electronegative, while metals are highly electropositive. So talk about reduction. Reduction is the addition of an electropositive element to a substance and removal of an electronegative element. First, let's take for example, we'll have iron 2 chloride. We'll have iron 2 chloride. So react with chlorine. Chlorine is highly electronegative. So you have to give FeCl3. So what happened is that what? Iron 2 chloride have been what? Oxidized to iron 3 chloride because an electronegative element, which is chlorine, has been added to iron 2 chloride. So this is oxidation. So iron 3 chloride oxidized, so which is oxidation, while chlorine is reduced, which is what? Reduction. Reduced. So it undergoes reduction. So iron 2 chloride undergoes what? Oxidation, while chlorine undergoes what? Reduction. So oxidation, addition of an electronegative element to a substance, and the removal of an electropositive element from a substance. If I use another example again, this is sodium reacting with fluorine, which is highly electronegative, to give you sodium fluoride. So you have 2 here, so you have 2. So you can see that to give you sodium fluoride. So sodium, we have added an electronegative element to sodium. So sodium is oxidized. Addition of an electronegative oxidized, where fluorine is highly electronegative, while fluorine is reduced. So oxidation takes place here, and reduction also what takes place. So oxidation is the addition of an electronegative element to a substance and removal of an electropositive element, while reduction is the addition of an electropositive element to a substance and removal of an electronegative element. So that's the definition of oxidation and reduction in terms of addition and removal of electronegative and electropositive elements. So oxidation reduction. So we want to look at redox in terms of oxidation number. When we talk about oxidation number is simply means the charge on an ion. For example, if we have ammonium ion, NH4 plus, the charge is +1. Example, if we have carbonate ion, the charge is -2, which is the oxidation number. If we have phosphate ion, the charge is -3. So the oxidation number is equal to what? -3. So when we talk about oxidation number, it simply means the charge that is present in an ion. Now, if we're referring to atom or element, the oxidation number is the number of electrons the atom have to gain or lose in order for it to attain its nearest noble gas configuration. That is what we call the combining power of an element, the combining power of an atom, the combining power of an element, the number of electrons the atom have to gain or lose in order for it to attain its noble gas configuration. Like metals ionize by losing electron. When they lose electron, they become positively charged to attain their noble gas configuration. Let's take, for example, this is calcium. Calcium is equal to what? 20. When it ionizes by losing electron, it will attain the nearest noble gas configuration. When you lose the electron, you have calcium ion, which is equal to what? 18. So the oxidation number here is +2. Oxidation number for calcium is +2, because the number of electrons it has to lose for it to attain this noble gas configuration, which is the combining power, is what we call what? The oxidation number, the charge that is present in an ion. Let's take, for example, for a non-metal, oxygen, for example, oxygen is 8. So oxygen has 6 electrons in the outermost shell, so it needs 2 electrons to complete its what? Octet state. So they ionize by gaining electrons, which are non-metals. So when the oxygen gains electron, needs 2 electrons, so oxygen will gain 2 electrons, O2 minus. So the oxidation of the number of electrons now be equal to what? 10. It has attained the nearest noble gas configuration. So the oxidation number of oxygen is equal to what? -2. For example, chlorine is 17. It needs 1 electron, which is a non-metal. It needs 1 electron to complete its what? Octet state, to attain the nearest noble gas configuration. So when it gains 1 electron, so you have Cl what? Minus. So the oxidation number is equal to what? -1. So when we talk about oxidation number, it is the charge that is present in an ion. The charge or the combining power of an element, or the number of electrons an atom has to gain or lose in order for it to attain its noble gas configuration. So whenever there's an increase in oxidation number, we talk about oxidation. Oxidation is the increase in oxidation number, while reduction is the decrease in oxidation number. Let's take, for example, this is a redox reaction where we have, let me erase this so that I will have enough space. Let's take, for example, this is a redox reaction. Magnesium reacts with hydrogen ion to give you magnesium Mg2 plus magnesium ion plus what? Hydrogen gas or hydrogen molecule. The oxidation number of magnesium is 0 here. The oxidation number of hydrogen here is +2. The oxidation number of magnesium here is +2. The oxidation number of hydrogen here is 0. So there's an increase in the oxidation number from 0 to +2. So we say what? Magnesium is what? Oxidized. So this oxidation, magnesium, which is the increase in oxidation number from 0 to +2. Why this one is what? Reduction from +2 to 0. which is reduction, decrease in oxidation number from +2 to 0. This is what? Reduction, which is decreasing what? Oxidation number. So it's as simple as ABC. So oxidation is the increase in the oxidation number, while reduction is decrease in oxidation number. If I take another example, let me just erase and take another example to illustrate oxidation and reduction in terms of increase and decrease in oxidation number. So zinc plus copper ion to give you zinc ion plus copper. So oxidation number of zinc here is 0, oxidation number of zinc, copper here is +2, oxidation number of zinc here is +2, oxidation number of copper here is 0. So you can see zinc is oxidized from 0 to +2, which is increase in oxidation number, which is oxidation. There's an increase in oxidation number from 0 to +2. Yeah, there's a decrease in oxidation number from +2 to 0, which is what? Reduction. So in terms of oxidation number, oxidation is the increase in the oxidation number, while reduction is the decrease in the oxidation number. So you have to identify the oxidation number. So it's as simple as ABC. So still on redox, we want to look at oxidizing and reducing agents. What are oxidizing agents? An oxidizing agent is substance that undergoes reduction, the substance that is reduced in a reaction. That means the substance that gains electron, the substance that hydrogen is added to and oxygen is removed from, the substance that decreases in oxidation number. That's what we call what? The oxidizing agent. Examples of oxidizing agent. Non-metals are oxidizing agent because non-metals ionizes by gaining electron. When they gain electron, they become negatively charged. So examples of oxidizing agent are oxygen, chlorine, fluorine, and other non-metals. Concentrated sulfuric acid, potassium manganate, potassium heptadichromate, and others. So when we talk about oxidizing agent, it is the substance that is reduced in a reaction, the substance that gains electron, the substance that hydrogen is added to, and the substance that oxygen is removed from, the substance that decreases in oxidation number. And these are examples of what? Oxidizing agent. Then we want to talk about reducing agent. A reducing agent is the substance that undergoes oxidation, the substance that is oxidized, the substance that loses electron, the substance that oxygen is added to and hydrogen is removed from, the substance that increases in oxidation number. So as example, metals are what? Are reducing agents because metals ionize by losing electron. So metals are reducing agent. Examples are active metals generally, hydrogen, carbon 2 oxide, hydrogen sulfide, and others. These are examples of what? Reducing agents. So when we talk about reducing agent, it's the substance that undergoes what? Oxidation. That is the substance that loses electron, the substance that oxygen is added to or hydrogen is removed from, and the substance that increases in oxidation number. So these are examples of what? Reducing agent. So before a typical examination question, it's an exam style question. In each of the following equations, state which reactant is oxidized, which reactant is reduced, the oxidizing agent and the reducing agent. So we want to identify the reactant that is oxidized and the reactant that is reduced, and the reactant that is the oxidizing agent and the reactant that is the reducing agent. Now, from our previous lecture, we are meant to understand that what? Oxidation is the addition of oxygen, while reduction is the removal of oxygen. So the substance that oxygen is added to is the substance that is what? Oxidized. The substance that is oxidized is the substance that oxygen is added to. The substance that oxygen is removed from is the substance that is what? Reduced. So here you can see that lead oxide is what? Reduced from this equation. This is reduced. So lead oxide is reduced. It's reduced to lead. While hydrogen is oxidized. Hydrogen is oxidized to water. So what is reduced is what? Lead oxide, and what is oxidized is hydrogen. So we want to identify the oxidizing agent. The oxidizing agent is substance that is what? Reduced. That is the oxidizing agent. So lead oxide is the what? Oxidizing agent. Lead oxide is oxidizing agent, while hydrogen is what? The reducing agent. Reducing agent. Hydrogen is the reducing agent. The reducing agent is substance that is oxidized. So it is hydrogen that is what? Oxidized. Now let's look at this one. The oxidizing agent, the substance that is oxidized, the substance that gains oxygen, the substance that oxygen is added to it, the substance that is what? Oxidized. Why the substance that is reduced? That means carbon 2 oxide is what? Oxidized. So carbon 2 oxide is the reducing agent. Is the reducing what? Agent. Why silver oxide is reduced? The substance that oxygen is removed from is reduced. So silver oxide is the what? Oxidizing agent. So it's as simple as what? ABC is just for you to identify the substance that is oxidized and the substance that is reduced. The substance that is oxidized is the reducing agent, while the substance that is reduced is the oxidizing agent. So it's very, very simple. So attempt as many questions as possible and feel free to reach out to me. So this is another example, typical examination question. In each of the following equations, state which reactant is oxidized, reduce the oxidizing and the reducing agent. We all know that the substance that is oxidized is the substance that gains oxygen. The substance that oxygen is added to is the substance that is oxidized, while the substance that oxygen is added to and hydrogen is removed from is the substance that undergo oxidation. While the substance that undergo reduction, which is the substance that is reduced, is the substance that hydrogen is added to and oxygen is removed from. So if we are to identify this, you can see that what SO2, which is sulfur 4 oxide, is reduced to what? Sulfur. So this is reduced. Is the reduction. It's reduced to sulfur. Sulfur 4 oxide is reduced to sulfur. So sulfur 4 oxide, since it undergoes reduction, it is the what? The oxidizing agent. Sulfur 4 oxide is the oxidizing agent. Now if you look at hydrogen sulfide is oxidized to water. Oxygen is added to hydrogen sulfide. So hydrogen sulfide, this is what? Oxidation. Oxidation is oxidation. So since it is oxidized, hydrogen sulfide is the what? Reducing agent. Hydrogen sulfide is the reducing agent because it is substance that is what? Oxidized. It's a substance that undergoes oxidation. Now let's look at the second question. If you look at, want to identify the substance that is reduced and the substance that is oxidized. Now, when we talk about reduction, reduction is the addition of hydrogen. So the substance that the hydrogen is added to the substance that is reduced. So ethane is reduced. Ethane undergo reduction. Ethane is reduced. So ethane is the oxidizing agent because hydrogen is added to ethane. Is reduced to what? Ethane. Ethane is reduced to what? Ethane. So ethane is reduced. So ethane is the oxidizing agent. Why hydrogen is what? Why hydrogen is oxidized? Hydrogen is oxidized. So hydrogen is the reducing agent. Hydrogen is the reducing agent. So the substance that hydrogen is removed from is the substance that undergo what? Oxidation. So hydrogen is oxidized, while ethane is what? Reduced. So the oxidizing agent is ethane, while the reducing agent is hydrogen. So it's as simple as A, B, C. So just attempt as many questions as possible and reach out to me. So before I say tax, these are typical examination questions. Attempt these tasks and also attempt as many questions as possible. And feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. Feel free to reach out to me if you encounter any challenge or any difficulty and attempt as many questions as possible. Thank you very much. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Subscribe to my YouTube channel, Geometry. I'm Mr. Joe. Thank you very much.